Alright, we're picking up with the second part of 8.1, and we're learning our third method on how to solve a quadratic equation. We're going to look at completing the square. This method will work for every quadratic equation you're ever presented with to solve. Here is the process. So a quadratic equation in this form, the first thing that you want to do is you want to have the leading coefficient, the number in front of x squared, be 1. So if it's not 1, you need to divide both sides by a. Then you want to rewrite the equation so that all the terms with variables are on one side with the constant on the other. So the constant term is the part with no variable on it, and it needs to be on one side by itself. Now we complete the square. So we're going to take half the coefficient of x and square it. And this will produce a number. This number we're going to add to both sides of the equation. Then we're going to factor the trinomial that we have on one side, and we're going to use the square root property to solve for x. It is rather lengthy, but it has to be because it works for every quadratic equation ever presented to you. So what we're going to do right now is we're just going to practice step 3. So we're going to do some warm-up problems. So step 3 says take half the coefficient of x and square it. So right here, it's actually p, so this letter is interchangeable with any letter of the alphabet. So we want to take half of negative 12 and get negative 6, and then we want to take negative 6 and square it. So the number that we add here is 36. So you can see that now we have created a trinomial. And this trinomial then factors into a perfect square. So every time you complete the square, the trinomial you have will factor into the same expression twice. What will go here is p minus 6. And the number that always goes in here is the value you got when you took half. So when we took half of negative 12, we got negative 6. That's always the number here. So let's try one more time. Take half the coefficient of x. So we want to take half of 1/2, which we multiply across and get 1/4. And then to finish step 3, we want to take 1/4 and square it. So we take 1 times 1, 4 times 4. So the number we're adding on is 1/16. Now, this trinomial that we have now produced factors into the same expression twice. What goes in there is x and the number we got when we took half. So plus 1/4. Now let's put the entire completing the square process to work. So solve by completing the square. First, is our leading coefficient 1? Is the number in front of x squared 1? It is. 2, move the constant to the other side. So we're going to write x squared minus 2x equals 10. Step 3, take half the coefficient of x. So we want to take half of negative 2. We get negative 1. Take negative 1 and square it and get 1. This number is added to both sides. So we get x squared minus 2x plus 1 equals 10 plus 1. So this over here is 11. And then this factors into the same expression twice. And remember what goes in there. You split out x squared to x, and the number is what you got when you took half, so minus 1. Now you can see the process of completing the square is to move all the variables listed individually to show only one time within a power of 2. So now what we have is an expression that we can apply the square root to. So I'm going to take the square root of x minus 1 squared equals the square root of 11, always remembering when we physically draw in the square root symbol to also include plus or minus. Now the square root of this square becomes x minus 1 equals plus or minus the square root of 11. To finish, we add 1, so we get x equals 1 plus or minus the square root of 11. And these are our answers. Now, if MATLAB doesn't have a plus or minus key, remember you can write two separate answers. One plus square root of 11 and one minus square root of 11. So let's try again. This next example does not have a leading coefficient of 1. So the first thing we must do is divide all parts by 9. So we get x squared minus, this fraction reduces by 3, so I'm going to reduce it to 8/3 x equals negative 13/9. Now the next part of completing the square is that our constant has been moved over. And we can tell that negative 13/9 is already over on one side by itself. So the next thing we want to do is we want to take half the coefficient of x, so we want to take half of negative 8/3, which I can take, since I'm multiplying fractions, I can take 2 into 4 twice, or 2 into 8 4 times, sorry, 2 goes into 8 4 times, and multiply across, so I get negative 4/3. Now the full completing the square process is to now square this. So I'm going to take negative 4/3 and I'm going to square it to 16/9. That 16/9 is going to be added to both sides. So I get x squared minus 8/3 x plus 16/9 equals negative 13/9 plus 16/9. This expression here factors into the same expression twice. Remember, x squared becomes x, and what goes into the parentheses is what you got when you took half. So minus 4/3 equals 3/9. Now you might think to reduce 3/9, but I'm actually going to leave it alone because I know my next step is to take the square root. And if I leave 9 down here, I can easily take its square root. So I'm going to take the square root of x minus 4/3 squared equals plus or minus the square root of the entire 3/9. This becomes x minus 4/3 equals plus or minus. Now from chapter 7 we learned that we can apply the quotient rule, so we can apply the square root to the top and the bottom. So now I get x minus 4/3 equals plus or minus the square root of 3/3. I'm going to add my 4/3 over. So I get x equals 4/3 plus or minus square root of 3/3. And here's where you have to realize how to write your final answer. We had said in part 1 of chapter 8, section 1, that these parts stayed separate if there was an I involved. Well, there is no I in this answer, so these separate expressions must share the same denominator. So I'm going to write 4 plus or minus the square root of 3 all over 3, and that will be my answer. So let's try again. X squared plus 4x plus 13 equals 0. Leading number is already 1. Let's move our constant. So x squared plus 4x equals negative 13. I want to take the coefficient of x and take half of it. So I want to take half of 4, which is 2, and then I have to square that. So 2 squared is 4. 4 is added to both sides. So I get x squared plus 4x plus 4 equals negative 13 plus 4. This trinomial factors. It factors into the same expression twice. What goes here is you split the x squared, and the number that goes in here is what you got when you took half of 4, so plus 2, equals negative 9. Now my x's have been condensed into a single spot within a power of 2. So I can take the square root of both sides, not forgetting my plus or minus. So I get x plus 2 equals plus or minus, this is 3i. We are now always going to take the square roots of negatives and produce an imaginary value. I'm going to subtract my 2, and I get x is equal to negative 2 plus or minus 3i. And those are my two answers. Final one. We would first divide all terms by 4 because I need a leading coefficient of 1. So I get x squared plus 5/4 x plus 5/4 equals 0. I now need to move my 5/4 to the other side. So I get x squared plus 5/4 x equals negative 5/4. I am now going to take half the coefficient of x. So I'm going to take half of 5/4, and I'm going to get 5/8. I am going to take 5/8 and square it. So I'm going to get 25/64. This value is added to both sides, so I get x squared plus 5/4 x plus 25/64 equals negative 5/4 plus 25/64. The trinomial now factors. This trinomial factors into the same expression twice. It's always the same rule. The x squared becomes x, and the number that goes inside is what you got when you took half. So plus 5/8. Now to add these fractions, we dare not forget that we need an LCD. So my LCD is 64. So if this is going to become 64, that's by way of 16. 16 times negative 5 is negative 80. So now I have x plus 5/8 squared equals negative 55/64. Now I can take the square root of both sides. Remembering my plus or minus. So the square root of a square cancels each other out, so I get x plus 5/8 equals plus or minus. The square root of negative 55 will be I root 55, and the square root of 64 will be 8. I'm going to move over my 5/8 by subtraction, so I get x equals negative 5/8 plus or minus I root 55 over 8. We can see the difference now between this answer and the one at the top that we did. These values have an I, so these parts must stay separate. So our answer is in its best form.